Hey everybody, this is Mr. Longo, and in this video we are going to cover sinusoidal application problems, which basically means you have to draw a sine or cosine wave and write an equation about it, and then if you have to answer more questions, you do so. They're really not as hard as they appear to be as long as you draw the correct picture. So at this point, you've already learned how to graph sine and cosine waves. You have also learned how to write the equation of a given sine or cosine graph. So what we're going to do in this is just take it a step beyond. So yeah, just follow along. It's not that bad. Really all you need is a top, bottom, middle, left, and right, and that'll get you through. So check it out. A Ferris wheel has a diameter of 60 feet with a minimum height at 3 feet above the ground. And then after the boarding is done and the ride begins, you started timing. So you know how like when you get on a Ferris wheel, you got to wait for every car to be loaded, and once it's all loaded, the ride goes. And you start your stopwatch and you notice that it takes you 2 seconds before you get to the top. And it takes 10 seconds to make a full revolution. So write the equation to model your height at any given time during the ride, and then figure out what's your height when the ride began and after 15 seconds, and you can actually figure it out for any amount of time until it's over. So let's go. After reading all of that, as I mentioned at the beginning, you basically need a top, middle, and bottom, and then a left and a right. Now the easiest way to do this is to come up with a little diagram that represents the situation with 3 along the bottom, and then you need 3 going up and down as well. Now you don't have to draw these to perfect scale because you're going to be working with a bunch of different numbers. So the top and bottom are going to be based off of what you were given. So it says it has a minimum height of 3 feet off the ground, but you have a diameter of this Ferris wheel of 60 feet, so that takes you up to 63. So then, of course, you need your node line or your center line, and that is going to be half of the diameter. So your if your diameter is 60, the radius is 30, which makes this 33. Now you need a start and a stop. So 2 seconds after you started timing, you're at the top. So we're going to have a 2 for our first tick mark. And then it says it takes 10 seconds to make a full revolution. So 10 seconds past 2 would be 12 seconds. Do you need the 7 in the middle? Not really. It's not going to help you much, but you can put it there if you want. So then, after you read this again, it says 2 seconds after you started timing, you were at the top. So you're going to have a starting point at 2 all the way up at 63. And then it takes 10 seconds to make a full revolution. So once you're at your 12th second, which is 10 seconds later, you're back at the top, which means at 7 seconds, you are at the bottom. Because these, of course, are sinusoidal, and we're going to just have a little graph that looks like that. Again, do you need the 7 to know what that number is? Not really, but that's what this graph is going to look like. And then, how we learned in our previous videos, you can just write an equation of the graph. So since this is starting, we're going to make a couple of notes here. Since this is starting at the top, we know that is a positive cosine graph we're going to have to write. Our middle line, remember, this is our middle line. This is our vertical shift. So we're going to end with a plus 33. We have a horizontal shift of 2 seconds to the right. So that's a lot of information that we have already. The only thing we need to really find now is our b value. And remember, from the b value, we are going with a graph from 2, which is less than or equal to x, which is less than or equal to 12. Now, when we're graphing, we start with the b and we go find our start and stop. when we're writing the equation, we already know what our start and stop is. We have to work backwards to find our b. So the first thing you have to do is turn this starting point to a 0 by subtracting 2 from everything. And that's going to give us 0 is less than or equal to x minus 2, which is less than or equal to 10. From there, you need to get that b value by turning this to either 2 pi or 360 degrees. It really doesn't matter if you want to be in degrees or radians. You will still have the correct answer once you decide to type it into your graphing calculator. You just make sure you're in the appropriate mode. So, most people like degrees because it's what you're most familiar with. So just take your 360 and divide it by 10, and you will get that your b value has to be 36. So your final equation for this part is 0 is less than or equal to 36 times x minus 2, which is less than or equal to 360, which takes us back to 1 standard period for sine. So now all we have to do is put the equation together. That makes our equation y is equal to, we have an amplitude from 33 to 63 and from 3 to 33, aka half the diameter of 30. It's positive because we start at the top. Cosine. And now we have our b portion. So we have 36 times x minus 2 because we were shifted 2 to the right. And then we have our vertical shift of 33 up. And that is the equation that models this problem. And from there, you can find a whole bunch of different things. So if I pull up the calculator, I already typed it in just to save time on the video. Remember, your calculator will automatically open up parentheses, so you just have to be careful to close it twice. But I've already typed it in. Your window, your x minimum should always be 0, even though we're starting at 2, and the x max is 12. Y min and y max could easily just follow what you have here. So this y minimum could easily be your minimum height of 3 and your maximum height of 63. And then all you're going to do is press graph, and you're going to see what you wrote. So if this matches your picture, minus the fact that I said you should always start at 0 and come backwards a little bit, and the reason for that is so you know where to find your starting height. Because it says, what was your height when the ride began? And after 15 seconds. Well, that's easy to do in multiple ways. But the easiest way is probably just to click second graph, which takes you to a table. And now you can just scroll. So at 0 seconds, when you first started timing, remember, you weren't at the top when the ride began. It took 2 seconds. So you're at 42.271. And then 15 seconds, that's simple enough where you can just scroll. Otherwise, you can just use the value function. But 15 seconds in, you're at 23.729. And those are the answers to your question. So when you first began, your height was 42.271 feet. And then after 15 seconds, you were at 23.729 feet. But that's it. That's how you read a sinusoidal application problem and write the equation. So there's one more example for you. I would like you to pause the video and just see if you can come up with the model this time, or the equation, and just see if you can come up with a little drawing and all that, and then press play when you're ready to see it happen. Give it a shot. Okay, so this one, you have a sawmill with a 20-foot wheel, and its lowest height is 2 feet below the river's surface. So if you don't know what a sawmill is, it's just one of those, almost like a windmill that goes through the water, and it's used to grind grains. So we're going to come up with this little chart again. Since we're starting below the surface, we're going to have a -2. And then we have a 20-foot wheel. So that's going to take our top up to 18. And 10 is your radius, which brings this guy to 8. So now you have your bottom, middle, and top, all of which you need. It doesn't say 2 seconds after. All it says is that you notice that it takes 3 seconds for the paddle to go from the bottom to the top. So you can use 0 for this one. And then it's 3 seconds to go from the bottom to the top. So your graph looks a little bit like this. Bottom to top. One thing you must absolutely do, though, is go back to the bottom. Remember, when you are working with sinusoidal type of applications, you need to always have one full cycle. So if you just went from 0 to 3, you would need to go all the way out to 6. And then all you really have to do is come up with a few things. So you know what your amplitude is. It's 10. We are starting down at the bottom, so it's a negative cosine this time. Your vertical shift is going to be +8. And you just have to come up with your b value now because there is no horizontal shift. So remember, to do that part, you're just from 0 is less than or equal to x, which is less than or equal to 6. And how would you turn that to 360? Well, your b value would just have to be 60. So your equation for this, you should have come up with y is equal to a -10 because we're at the bottom with an amplitude of 10. And this is cosine. Our b value is 60. And then there is no horizontal shift, so you don't really need to even write the x in parentheses, but I know how it sometimes makes it easier to read with a vertical shift of 8. And that's it for this video on sinusoidal application problems. This is Longo and I'm out. See you, bye.